Hi guys, it's Mrs. Hudson. I wanted to talk to you guys a little bit today about transformations of functions using vertex form. If you guys recall from what we've been doing recently, this is vertex form, y equals a, and then if we have a parabola, it would be parentheses x minus h squared plus k. And you guys learned that h and k were very special because if you take h and k and put them together, they give you the turning point of the parabola, and when you have the h, you can determine the axis of symmetry of the parabola. So from vertex form, though, we can get a lot more information about functions. The functions don't have to be just quadratic functions. They could be quadratic, they could be cubic, they could be absolute value, they could be any kind of function that we want or that we're given. For the lesson, we're going to focus only on quadratics, which are your parabolas, and your absolute value functions, which look like these. We're going to talk about that in a few minutes. So when you look at an equation when it's written in vertex form, this number out in front, in this case it's a 2, that is your a. That number is going to tell you the slope of the right-hand side of what we call a parent function. A parent function is basically the initial function. It's what you have when you have just a very basic plain function. So for a parabola, the parent function would be y equals x squared. If it was an absolute value, the parent function would be y equals the absolute value of x. So it's a very basic standard function. What you then do is you create what I consider to be like little baby functions. And when you do that, what you're going to do is you're going to add numbers into the front, you're going to add numbers in the parentheses or inside the absolute value symbols, and you're going to add numbers afterwards. Each one of those numbers is going to tell you something else. So the number sitting in front is going to tell you the slope of the right-hand side of your whatever the function might be. If it's a parabola, the left-hand side would then just be like a mirror image of it. So you get that U shape. Also, this number out in front, if it's negative, if you guys remember, if a is ever negative, we get an inverted function, okay? So remember that when you had a positive x squared, your parabola would look like this. We thought of it like a smiley face. And if it was a negative x squared, it would look something like this, and we thought of it like a frowny face. So this number is going to tell you the steepness of the function, and it's also going to tell you whether or not it's inverted. The number inside is going to tell you your left or right movement. So remember, the formula has x minus h. So this number in here is actually the opposite of what you would think it would be when you're actually moving it on the function. And I always think of it as the numbers trapped inside the parentheses or the absolute value symbol, so it goes kooky and it ends up going the opposite direction. And then the number at the end is going to tell us if we're going up or down. Positive would go up, negative would go down. If you look at all the notes that you're being given, everything is explained in these little orange boxes about the direction you would move. Okay, so let's look at an example of that. So let's say we had an absolute value function, and it looks like this. Y equals 2 times the absolute value of x minus 4 plus 3. This red function right here is called the parent function, and it is y equals the absolute value of x. If we move it according to this set of rules, we get a little baby function. Okay, not really a technical term, just the way I think of it. They're like little baby functions. So what's going to happen? The 2 is going to tell us that it's going to get a little bit steeper. Its slope is going to increase. There is no negative, so it will not be inverted. The x minus 4 really tells us that it's really a positive 4. So it means that from the vertex here, which is at the origin, we are moving 4 units to the right. And then this tells us we are moving 3 units up. So all that information in here can get us the graph of the new function. And conversely, if we were to take these functions and look at a picture of them, we could figure out what the equation would be. So basically our goal today is look at a picture of a graph, try to figure out what its equation would be when you're going from a parent function to a quote baby function, And then we're also going to take the equation and try to see what the graph would match up and look like. Okay, so in this example, the vertex was moved to the right, 4. That's what we call a translation. It was slid over. The vertex was moved up. Again, that's what we call a translation. It was slid up. And it became narrower. The slope became a little bit steeper, so that's what we call a dilation or scaling. Okay, let's look at another example. Okay, so let's say we have this absolute value function. The negative is going to tell us that it's inverted, so it's going to go upside down. Okay, the number out in front of the absolute value symbols is still a 1. It's a negative 1, but still that A is a 1, negative 1. So we're going to make the slope stay the same, but it's going to become inverted. This plus 2 inside the absolute value symbols is going to tell us to move the original 1 left 2, and this is going to tell us to move up 3. So if you have your parent function, which is this v right here, of an absolute value function, we've turned it upside down, we've moved the vertex left 2, and we've gone up 3. So that's another example. Let's try another. Okay, let's say you're writing the equation of this graph here. Okay, the parent function is this v, the teal looking v. Hopefully you can see the color. And then this is the new one here. So the question is, what did we do to it? So let's just jot down what we actually did to this. It is not inverted. Okay, so A is not going to be negative, but A looks like it got a little bit steeper. So it no longer has a slope of 1 like this one, up 1, right 1. It now has a slope of up 2, right 1. So our slope of that is now a 2, so A is equal to 2. The vertex did not move left or right, so the H is going to be a 0, and then the K, it moved down, so it's going to be minus 3. So when we write this equation, it's going to be y equals 2, and then the absolute value symbols. You can write x minus 0, or you can write x plus 0, or you can just write x, and then it's minus 3. So it's saying we made it narrower, we made its slope a 2, we didn't move left or right, and we moved down 3. Okay, moving on. Let's say we have an example like this. We're now going to determine, we're going to try to just explain what would have happened in this one. So if you notice, there's no A showing here. So that's like an invisible 1. Positive 1 means we have not made it any narrower or any wider. We did not invert it. All we did was move. This gives you the left or right. Okay, remember that you're going to go the opposite of what you would think. So normally when you see a minus 6, you would think left. So we're going to go right. This is meaning we're going right 6 because H equals 6. And since K equals 5, that means we're going up 5. So you are taking the parent function and you are moving according to those directions. Okay? All right, so now let's look at another example. Let's say you had the parent function of y equals x squared, and you were shifting it 3 units to the right and 6 units down. So if this is vertex form, you're going to have y equals, we're not changing whether or not it got wider or narrower, and we're not inverting it. So all we're doing is we're going to keep that as a 1. You don't even have to show it. Going 3 to the right would be x minus 3. It would be squared. And then down 6 would be minus 6. Okay, so that's determining the equation from some information you've been given, or taking the information that you've been given in an equation and try to figure out what directions you're moving. Okay, so next, I just wanted to explain one more thing kind of as an overview. Vertex form can be changed depending on what the function is. And it always kind of looks the same. Here I have the exact same thing, but I'm squaring it. Here I'm cubing it. Here I'm taking parentheses away and I'm making straight lines because I am making an absolute value function. So while the parent function can change, if you're adding or subtracting the exact same numbers, what you're doing to that parent function will be the same. Okay, and just as a reminder, your parent function for a parabola would be y equals x squared, so it's going to look like this. your parent function for an absolute value is that V, so it's going to look like that. And those are the only two we're going to focus on. If we were in school, we'd probably do a little bit more because we'd have the graphing calculator. But being that we're home and it's a little bit hard to learn this way and we don't have those calculators, we're just going to stick with those two for now. Okay, you will get into more of this later on in high school, so we're giving you what you need just for now. Okay, now the next thing I want to do is I just want to show you how to enter this in when you're doing this on Delta. Okay, so I'm going to wait for the computer to go back on, and we're just going to do an example here. Okay, so this example, I want to get a different example. Hold on. Okay, so here you see you have an absolute value function. You see a V. Okay, now it is being inverted, which means right here in front of the X, you're going to want to put a negative sign. Okay, then what you're going to want to do is you're going to want to figure out how are you moving from here to here. Well, it looks as though we're going left 3. So we're going to put minus 3 here. And then what we're going to do is, you can see that this is a discovery one. So what it's doing is every time you make a change, it's moving it for you. So you can actually visibly see the graph changing. Then what we're going to do is we're going to drop down 6. So we're going to change this number here to a negative 6. And when we click out of that, it shows us that that's what it's going to look like. Okay? Now, let's just say that you now are doing these questions here. Okay, so this one is asking you to pick from the choices what matches up with this. So it's saying which one matches up, and it's not giving you, it's giving you the absolute value of X there. So what's happening is you're not inverting it, you're not changing its slope, so none of the numbers in front are going to change. What you're doing is you're going left 1. If you look here, you're going left 1 and down 1. Now remember, inside the absolute value symbols, that left 1 is not going to be a minus 1, it's going to be a plus 1. Remember, it goes the opposite direction. So it's going to be a plus 1 inside, and then it's dropping down 1, so it's going to be a minus 1 outside the absolute value symbols. So it's going to be a plus 1 inside, because you're going left 1, and then a minus 1 on the outside. Okay? Now, the other type of question you could end up with is in this section here. And this is going to be basically the same assignment you're going to do for 2 days. And when you do a review of this before we, give you another checkpoint, you're going to be doing the same thing, but just on paper, just not on Delta. Okay? So this one here, remember you have to think about, this one is not showing you the parent function. So you have to imagine where that parent function is. That parent function would have been a U up here. Now it does look like it's getting narrower, which it is, and you can see that your only choices are 4s. So you know that it's having a slope change to go to about 4. Now the other thing is that it is inverted. So you're definitely going to have a negative in front of that 4. Then what you're going to do is you're going to go left 3. So that means you're going to have a plus 3 inside the parentheses, which narrows you down to these two. And then it's going to go down 4, which means you'd have a minus 4. So you would end up with this choice right here. Okay, so I just wanted to give you a quick overview on Delta so it's a little bit easier for you to understand how to enter the information. And like I said, when we do a mix-up on this, it's going to be an actual worksheet that you're going to write down. But for today and for tomorrow, you're going to be doing some of this on Delta.